All right, we're still looking at compound interest, but sometimes they want you to figure out the principal. So, like, for example, upon a child's birth, a deposit is made into an account. Assume that the account has an annual interest rate of 4.8% and its compounding is done quarterly. The question is, how much must they deposit now so that the child will have $60,000 when they're 18 years of age? So when I'm reading this, I'm like, I don't know what color to use. This is A. That's in the future. And our interest rate, that's our little R. And then what else we got here? Compounding is done quarterly. So that's our M. M is a 4. And time. How much time has gone by? Well, it was upon a child's birth and then at age 18. So time is 18 years. 18 years has gone by. So remember, this formula has an A, a P, an R, an M, and then N, which is M times T. So looking at the next slide, here we are. The future value is the 60,000. The rate was 4.8%, but remember you have to change that to 0.048. It was done quarterly, so quarterly is 4 times a year. And then N is M times T. Well, 4 times a year for the next 18 years makes N a 72. And so you can see there's the 72. And you put the 60,000 where the A is. And then there's the R and there's the M. P is what we're looking for. So what they did is they did all the math inside the parentheses like they did before. They took the 0.048, divided it by 4, and then added it to 1. And that gave them, let's see, when they divided, they got that. And then when they added it to 1, they got this number here. And you'll notice that, I didn't show it, but right here, since it's P times, you're multiplying it times all this stuff in parentheses, you would divide all that stuff in parentheses raised to the 72nd power on both sides. What you do one side, you got to do the other. So you divide this also by that. Doot. Because that cancels that and you're just left with P. So on your calculator, you have to take the $60,000 and divide it by this right here, which they went ahead and calculated it, but just type it into your calculator as 1.012 raised to the 72nd power. That will be fine. It will work. And so to the nearest cent, that's your answer. $25,418.76 is what they would need to deposit right now and leave it there for the next 18 years. Don't touch it. And then when the kid's ready to go to college, they'll have $60,000. But that's based on quarterly at 4.8%. If you can find a bank that'll give you a higher interest rate and compound it more times than just 4, you want to go for daily if you can find it. That's the best deal. Now, what's the next slide say? Another example. Okay, 1.4 million is to be invested now to be paid as 1.68 million in 2 years. Okay, here we go again. Okay, they're going to invest, I'll use green for the investment. 1.4 million is to be invested now. That makes this P. And it's going to be paid as 1.68 million. That's in 2 years. That's the future, so that's A. That's a terrible little A there. This is A. This is P. And then 2 years is time. It's going to happen 2 years from now. So my T is a 2. And then it goes on to say, assume an annual interest rate that is, what rate of investment will yield the 1.68 millions in 2 years? Okay, what rate? What rate? We are trying to figure out what R is. And then it goes on to say, assume an annual interest rate that is compounded monthly. So in this case, M is a 12. And so this should all show up on the next slide, and it does. A is 1.68 million. P is 1.48 million. M is 12. N is 24. Okay, N is 24 because they took it. It was 12 times a year for the next 2 years. That's where the 24 came from. And you'll notice they plugged everything in here. Now, this one's a little tricky because you're trying to figure out what the rate is. And the rate R is stuck inside the parentheses. So the first thing they did is they divided both sides by 1.4. So the 1.4 cancels out. And 1.68 divided by 1.4 actually comes out to be a 1.2. The next thing that they're going to do is they want to get rid of this 24. That is an exponent. The only way to get rid of an exponent is to do the opposite, which is a root. So they took the 24th root of both sides, the 24th root. 24th root would cancel out the 24th power. So when you get up here, the right side no longer has that 24th power. You're trying to solve for R. So the next thing they're going to do is subtract the 1, because that'll cancel out, but you have to subtract 1 on the other side. You actually can't subtract the 1 until after you have taken the 24th root. It's an order of operations thing. And then the last thing they're going to do to get R by itself is multiply by 12. Because if you look at it this way, it'll cross cancel out. Well, then you got to take the other side and multiply it by 12. And then what they did is they put all of this in the calculator. There's a button on your calculator that shows nth root, like that, or is it mth root? I don't have that calculator with me right now, but there's a button on there that you can utilize to get this answer. And these are really great calculators. They're programmed with order of operations, and you can plug it all in, and it comes out to be 0.0915, but your final answer, remember you have to multiply this times 100, so your answer should be 9.15%, which is a really big percentage. That would be great if you could get that. And the next slide is going to be some math lab examples. So I'm going to stop with the lecture and show you some examples.